All right, these are the answers to our Term 1 exam review. First page had a bunch of limits, and when we do a limit, the first thing we should always try to do is just plug a number in. So for this first one, put -5 into that, and we should get 2 times -5 squared. That's going to be 50 plus 10 plus 4, 64 is our answer on that. So that's first things first, we should always just plug it in. So for this one, if I plug that in, I get 9 plus 12 minus 21, which is 0. M squared minus 9 on the bottom is also 0. So when we talk about a limit, we get 0 over 0. That doesn't tell us anything, right? We got to do some work. And the work we do is one of two things. Either we do a little bit of algebra. We try to factor that into m plus 7, m minus 3 over m plus 3, m minus 3. Let the m minus 3's cancel. And so now I've got m plus 7 over m plus 3. And while that's not the same as this, it looks the same as this. So when we talk about a limit, we can let 3, put 3 into here, and whatever this equals, that's what the limit will be. So if I put 3 in, I get 10 over 6, which is 5/3. Okay? So that's one idea. Another idea is to use what we call L'Hopital's rule. So in a case like this, if we get that 0 over 0, we could take the derivative of the top, 2m plus 4, do the derivative of the bottom, 2m, try it again. If we put 3 into this, I get 6 plus 4, which is 10, over 6, 10, 6, 10, 6. We get the same answer. So it's always an option. For number 3, when we put 7 in, we're going to get 0 over 0. Again, that tells us nothing. So either we do a little bit of algebra, which in this case would be multiplying by what we call the conjugate, which is square root of x minus 3 plus 2. All right, and we multiply both top and bottom by that. What's going to happen on the top is we're going to get square root times square root, which is x minus 3. The outside inside will cancel, and you'll get -2 times 2, which is -4. Okay. And the good news about that is the top will turn into x minus 7. When we combine that x minus 7, we'll cancel the x minus 7 that's on the bottom. We get 1 over square root of x minus 3 plus 2. And now when I put 7 into that, I'm going to get 1 over 2 plus 2, which is 1/4. The other idea on this would be to do L'Hopital's, take the derivative of this. Everything else kind of goes away. And then once you have that derivative, put 7 into the derivative and go. Okay. On this one, I see we've got a delta x, and it's x plus delta x put into here. And then we've got a normal function here. So this is about recognizing what this is. This is the derivative of a function, and the function that we're describing is this 3 squared of x plus 5. So this limit is really representing the derivative of that function. So really what I'm going to do is just take the derivative of that function. If I rewrite that as 3x to the 1/2 plus 5, the derivative, bring the half down, 3/2 x to the -1/2, and then the derivative of 5 is 0. That's the derivative of that function, which is what this limit is representing. Okay? So we want to kind of recognize that in the moment. Number 5, if I put 2 into this, I'm going to get 16 plus 10 minus that will be 0 over 0. Again, 0 over 0 tells me doesn't tell me really anything. I got to do some work. T cubed, that's going to be a little hard for me to do any algebra on. So really this is a problem set up perfectly for L'Hopital's rule. Take the derivative of the top, which would be 6t squared plus 5 over derivative of the bottom, which is 1. And now try it again. And if I put 2 in this time, I get 6 times 4, 24 plus 5 gives me 29. So L'Hopital's rule works really nicely for something like that. For number 6, we're taking the limit of this piecewise function as x approaches 3. So this function looks like it should equal 4 over 2x minus 5 for everything, but for whatever reason at 3, it actually equals 11. So what you'd see is a little hole in the graph at 3, filled in circle up at 11, but we're more interested in what it should have, what did it look like it was, because that's what the limit is. So really it's just about recognizing that's what's going on here, and then putting 3 into this function and getting 4 over 6 minus 5, 4 over 1 would give us 4. That's what it looks like it should equal. However, there's a hole there, and a the dots up at 11. Number 7 gives us another function that instead of delta x, they've given us d in this case. But if we substitute that delta x kind of back in, we see that this is just like the one that was up here at number 4. This is the general derivative for some function. The function that we're talking about in this case is sine squared 3x. So when we take that derivative, we have to use chain rule. In fact, we'll have to use a couple chain rules to do that one. So the outermost function is the squared. So we'll put the 2 down, drop that to a 1, leave sine 3x the same, times the derivative of the next function, which would be sine. So the derivative of sine is cosine, leave 3x alone, times the derivative of 3x, which is 3. If you want to make that 6 sine 3x, cosine 3x, that would be fine too. But that would be our answer right there. That's the derivative of sine squared 3x, which is what this limit is representing. And then for number 8, we're asked for the limit as x approaches 3 from the right of this piecewise function. And so if we're coming from the right, we're coming from numbers that are greater than 3, so we're really only looking at this top part. We don't really care about this bottom part. So if I put 3 into there, I get 5 times 3 minus 2, which is 13. So from the right side, it looks like it equals 13. From the left side, it looks like it equals 10, which means we have a jump discontinuity there. So this is discontinuous at 3. It doesn't have a full limit at 3, but it does have that partial one-sided limit coming from the right.